Edexcel Core Pure, Matrices 4, Determinants and Inverses of 3x3 matrices. The inverse of a 3x3 matrix. The transpose of a matrix. The matrix obtained by interchanging the rows and columns of a matrix A is called the transpose of A, or AT. So in this example we can see matrix A, and if you take the first column and let that become the first row, and the second column becomes the second row, and the third column becomes the third row, you can create the transpose of A. Finding the inverse of a 3x3 matrix. This is quite an involved process, and it's well worth practicing this by hand several times. But the order of events is to find, first thing is to find the determinant of the matrix, then find all the cofactors, one for each of the elements of the matrix, replace each element with its own cofactor, take the transpose of this cofactor matrix, and this produces a matrix which is called the adjugate or the adjoint matrix. Divide this new matrix by the original determinant, and this will give you the inverse matrix. It's worth noting that if the determinant of the matrix is 0 at the beginning, then the matrix is said to be singular and the inverse does not exist. So here we have a 3x3 matrix M. So the first thing we would do would be to find the determinant, and if you want to pause the video at various stages to do the various steps, that would be highly recommended. So the determinant of M is minus 90, and that is by expanding along the first row. And then you need to find all 9 cofactors. So here we have the cofactor of the first element, notice the capital A1, and its determinant of 1, 3, 4, minus 2. Be careful with the cofactor B1, so it's the minor for B1 times the minus sign which is attached to this position in the matrix, so it's minus the 2x2 determinant. So if you want to try and find the other 7 cofactors, this would be a good point to pause the video. So now we have all 9 cofactors, and notice the change of sign in the 4 appropriate positions shown. Once we have all 9 cofactors, then we can create the adjugate of M. So the top row of cofactors becomes the first column, the second row of cofactors becomes the second column, and the bottom row of cofactors becomes the third column. So that's called the adjugate or the adjoint matrix. Once you've found the adjugate of M, then if you divide by the original determinant, you have the inverse. And again, it's worth noting that if you want to verify that the inverse is correct, then if you calculate M times its inverse of M on a calculator, it should give you the identity matrix. So here we're going to try and find the inverse of this 3x3 matrix, and we note that the first element is a K rather than a numerical value. So again, if you want to try this in terms of K as we're going along, that would be a good idea. So the first thing you can do is to create the matrix of cofactors, which I've called capital C as a reminder. So see if you can find all the cofactors for the 9 elements to create C. Then I'm going to transpose C to create what we've been calling the adjugate matrix. So I'm going to transpose C. And now to find the inverse of A, I'm going to divide the transpose of C by the determinant of A. So if you want to find the determinant of the original matrix, so the determinant of the original matrix should be 2 minus 2k, and there we have the inverse matrix in terms of k. So that brings us to the end of matrices for determinants and inverses of 3 by 3 matrices.